Hello everyone, this is Heading 10. In this video, we will learn chapter 7.1, applications of right triangles. We will learn three objectives. The first part, let's learn solve a right triangle. If I have a right triangle, for example, A, B, C. If I solve it, I just solve the angle of A and B and C. I provide you we need to provide the angle A equals how many degrees, B equals how many degrees, C equals how many degrees. And also we need to find the three sides. The opposite of A is A. That means we are looking for the distance, or we need to find the length of A. So A equals how many feet, or how many meters, or how many miles. And the opposite of B is B. Opposite of C is C. So we use the lowercase represent the length or the sides. And we use the uppercase capitalize the letter to represent the angle. So we need to find A, B, and C. So that's the way we solve a right triangle. So let's see the example. For this example, the given information is the angle B is 52.8 degrees, and we have A equals 10.7, and we have an right angle C. So we have learned that for any for any triangle, the angle A plus angle B plus angle C equals 180 degrees. That means A plus B plus C equals 180. And then A equals 180 minus 52.8 degrees minus 90 degrees. That means 180 minus 52. 52.8 degrees minus 90 degrees. What is that? We can use our calculator. 180 minus 52.8 minus 90. That's 37.2 degrees. 37.2 degrees. We find A, and how to find the B and C? I mean the length of B and C. So we have learned that tangent B equals opposite of B over adjacent. So tangent B or tangent, I just plug in the number, the angle, 52.8 degrees. Equal opposite B over A. A is 10.7. That means B equals 10.7 times tangent 52.8 degrees. We use our calculator. So first set up our mode in degree form, because here is degree. So degree, highlight the degree and click enter. And second mode, we quit. So 10.7 times tangent, here is tangent 52.8, close the parentheses. We got so the B, it's about 14.096. So round to one decimal place. That means keep one decimal here, because zero, the digit after 0 is 9 is greater than or equal to 5. So we need to add 1 to 0 here. So that's 14.1. It's about 14.1. How to find the C? So C is hypotenuse in a right triangle. We know the adjacent. That means cosine 45. Oh, sorry. cosine 52.8 degrees equals adjacent over hypotenuse. So cosine 52.8 degrees equals A over C. I can plug in A, that's 10.7. 10.7. So C equals, C equals 10.7 over cosine 52.8. So C is about, C 10.7 divided by cosine 52.8, close the parentheses, 17.69. So round to 1 decimal places, we need to round to, okay, here I need to be 7 because the number after 6 is 9. 9 is greater than or equal to 5. That means I need to add 1 to the 6. That's 17.7. 17.7. So we can do a summary because we find all the ABC, angle ABC, and the sides ABC. We can do a summary. I can say A equals 90 degrees, 37.2 degrees. B equals 52.8 is given. C is 90 degrees. And A equals, that's equals 10.7. B is about 14.1. C is about 17.7. Okay, that's a solution for the first example. And second one, solve the applications of right triangles. A boy holds a string 4 feet above the ground, and the string makes an angle of 42 degrees from the horizontal length of the ring. A string is 120, and the height of the kite to the nearest, find the height of the kite to the nearest foot. So let's see. The boy is holding the string, and the length of the string is from here to here is 120, and is looking for the height of the kite. So from here, this point to the bottom, to the ground here, is not to the C, point C. That means if we have this right triangle, we can find the A, and then plus this distance from here to here. And from here to here is 4 feet because I can move the 4 feet to here. That means first step, find the A from the right triangle, and then add 4. So how to find the A? The opposite over hypotenuse is opposite over hypotenuse, the sine. That means sine 42 degrees equals A over 120 degrees, 120 feet. So A equals 120 times sine 42. Use the calculator because it's asking the nearest foot. That means just keep the integers, no decimals. So 120 times sine 42 degrees, that's 80, is about 80 because we keep the integers 80, and then the 2 is too small, it's smaller than 5. That means we just cross out the decimals, just keep 80. So A is about 80 feet. And the height of the kite is from B to the bottom. That's use H, represent the height, equals or is A plus 4. That's about 84 feet. So that's the solution of this one. Let's move on to see this one. A woman stands 200 feet from the tower. eye level of 5 feet. That means from the bottom, from the ground to her eyes is 5 feet. Angle of elevation to the bottom of the clock. So from here to here, this angle is 42. The angle of elevation to the bottom of the clock to here. And to the top of the clock, so from eye to the top of the clock face, the angle is 45.4 degrees. Looking for the diameter of the clock face to the nearest foot, looking for from here to here. And if here is a right triangle here, and the distance from here to here, we can make that H1. And in the bigger triangle, we can assume from here to here is H2. So the diameter of the clock face equals H2 from here to here minus H1 from here to here. So it's easy for us to find H1, H2 because it's in the right triangle. So how to find the H1 and H2? H1 is opposite of the angle. And then we also know the adjacent. So we can use opposite over adjacent as tangent. Tangent in the smaller triangle, the small one, tangent 42. 42 degrees equals opposite H1 over adjacent 200. That means we can find H1 from this expression equals 200 times tangent to 42 degrees. So use calculator, 200 times tangent 42 degrees, close the parentheses. That's 180 because nearest foot means we just keep the integers, just keep 180. So H1 is about 180, that's feet. And in the bigger triangle, tangent 45.4 degrees equals opposite is H2 over adjacent is 100. So H2 equals 200. Did I say 100? So 100 times tangent 45.4 degrees. So what is H2? So 200 times tangent 45.4 close parentheses. Oh, I didn't see the answer. So 203, I can say 204 because 5 is greater than or equal to 5. That means I can round up round up to 4 because 3 plus 1. So that's 204. 204. And then the diameter equals H2 minus H1. So I can, is that 204? Let's go back and check. Oh, I know, where's my problem? Look at my number here. The angle should be 45.4. It's not 45.5. So let's do it again. So it's 202.8. That means I keep 203. So correct it. 203. So D diameter equals H2 minus H1 is 203 minus 108. That's about 23 feet. Okay, let's move on to see next one. Find the pitch angle of the roof to the nearest tenth. What's the pitch angle? So this is a roof. So this is a roof. The angle here we call pitch angle. If we are looking for the angle here, we at least we need to know something in this right triangle. So they provide us from here to here is 16 feet. That means from here to here is 15 feet. The half of 15 is from here to here. That's 8 because 16 over 2 is 8. So in this right triangle opposite, adjacent, so we can find the angle here. So we can pull out the right triangle here. So opposite 6, adjacent 8. That means we can use tangent. Tangent theta equals 6 over 8. 6 over 8 is 3 over 4. So theta equals inverse tangent 3 over 4. So we use calculator. Inverse is second tangent 3 over 4. Close the parentheses. So I didn't see. Nearest tenth. Round to the nearest tenth. So nearest tenth is here. The digit after the decimal point. That means I just keep this. So the number after 86 is greater than or equal to 5. So we have 36.9. So that should be 38.9. 38 or 36? Oh, 36.9. 36.9 degrees. So that's the pitch angle of this house. Okay, let's move on to the bearing of an object. What's the meaning of that? So in the navigation applications, we always mention about the bearing, that we use the bearing to convey the angular relationship from one point to another. So if we're starting from the point A or point O, we're going to any direction, maybe this direction or this direction. For example, this direction. First, we draw a horizontal line that represents west-east. And then we draw a horizontal line for north-south. And then we just measure this direction by bearing from here to here. For example, from O to the point A. And then how to describe the bearing from O to A? First, we put north or west for describing the first one. It's north or west for this one, because on the top half part, that's belong to north. So the bottom half part, that's south. This ray from O to A, this ray is on the top part. That means I put N here. So the first one, I must put N or south. And then second one, I put an angle. This angle is acute angle. That's a ray between the ray and the north-south line. Acute angle, that means the angle between 0 and 90 degrees. That means I must choose this one. This angle is acute. This angle is obtuse, it's more than 90 degrees. That means I put the acute angle, for example, this is alpha. I put alpha degrees here, degrees. And then later, the next term, I must put west or east. So it's on the east side, I put east. If it's on another direction, is here, I put the west. So that's the way we use bearing. That means the first term, I put the north or south. Second term, I put the angle between the ray and the north-south line. The angle must be acute. And then next term, I must put to the east or west or east. So we practice some examples. So for the first picture, the ray is on the top half parts. That means the first one I need to put north because north is on the top. The angle is acute angle between the ray and the north-south line. So acute angle is 42. So I put 42 degrees, and it's on the east side. I put east. And the second one is on the north part. That means north goes first. And then acute angle between here and here. That's 74 degrees. And it's on the west part. I put west. So look at this picture. The ray is on the bottom part. That means it's on the south part. Put S in front. Acute angle between ray and north-south line is 40. Put 40 degrees. And then it's on the west part. So put west. And the last example, the ray is on the south. Put the south in front. And then the angle is 69 degrees and it's on the east side. So that's south, 69 degrees east. So let's do some more practicing. Finding and interpreting bearing. First one, find the bearing from O to C. So here is O, here is C. So I must put north, south, west, east here. It's easier for me to write the bearing. So O to C is on the south first. And then the acute angle is 40 degrees. And it's on the east, put E. Find the bearing from O to B. O to B here. And it's on the north, so put N. And the acute angle between the ray and here. This is alpha, but it doesn't show us the alpha. And then it's on the west. I put the west here. How to find the alpha? From here, initial to end point here is 118. And we know this is a right angle is 90 degrees. That means I can use 118 degrees minus 90 degrees equals alpha. So that's 28 degrees. Okay, and number C, find the bearing from A to O. So the starting point is A, is not O. That means A is our origin. That means I need to draw a horizontal line for the west-east line and the vertical line for the north-south line. And then we are looking for this angle. So south goes first, and then last one that must be west because it's on the west part. How to find this angle? So in this right triangle, this is 90, this is 22. Use 180 minus 90 minus 22. So we have 180 degrees minus 90 degrees minus 22 degrees. That should be 68 degrees. 68 degrees. So here is 68 degrees. Oh, this image, they just pull out the OA to here and then show you how to find the 68. They have the same meaning. So this is a way how we find the bearing. Okay, next question. A plane leaves an airport heading south 32 degrees west at 320 knots, nautical miles per hour. This is a speed. I can use V, represent the speed. Determine the number of nautical miles south and number of nautical miles west that the plane travels in 1.2 hours. They provided us the time, round to the nearest nautical mile. So what's the meaning of that? So the starting point is A, is going to the south. South is in the bottom half part. It's going to this direction. And then the angle is 32 to the west. North, south, west, east. That means he's going to this direction. Then he got here after 1.2 hours. So it's looking for the number of nautical miles south and west. That means when he got to the position P. So how many miles of this airplane traveled to the south? How many miles? Oh no, this is the west. How many miles of this airplane traveled to the west? How many miles the airplane traveled to the south? That means it's looking for the distance from A to here, travel to the south, and then A to B, travel to the south. Yeah, so for example, the distance from here to the west is A. I can move this part here. So that means if we are looking for A and P, we move A and P in the same right triangle, and it has the given angle and one hypotenuse. So we can find the A and P. Okay, if you don't understand, please pause the video. Okay, if we have the angle A equals 32 degrees, opposite over hypotenuse is sine. That's sine 32 degrees. Oh, I forgot to mention that, how I got the hypotenuse. So we know that the distance equals velocity or the speed times t. And it gives us the speed is 320 and the time is 1.2 hours. So by the calculator, we can find the distance from A to P is 384. So you can use a calculator to test. So 220 times 1.2. Yeah, that's 384. Okay, so we know this, and we're looking for A and P. By the sine 32 equals A over hypotenuse equals A to the 384. So we can find the A equals 384 times sine 32 degrees. Use a calculator. That's 384 times sine 32 equals 203. Run to nearest mile, a nautical mile. That means I can just keep 203. So the A is about 203 mile. And how about the P? To the south. So adjacent over hypotenuse, that's cosine. So cosine 32 degrees equals P over 384. And the P equals 384 times cosine 32 degrees. So the P is about what? So 384 times cosine 32, close parentheses. That's 325.6. That's 326. 326 mile. Yeah, that's correct. Okay, so that's the answer for this question, is asking how many miles travel to the west, how many miles travel to the south. So looking for A and P. Okay, let's move on to next one. A boat leaves a marina heading north 52 degrees east at 6 mile per hour. That means this is the velocity or speed. After 1 hour, this is time. The boat make a 90 degrees counterclockwise turn to a new bearing of north 38 degrees west. if the boat travels this new course for 2 hours, a new time. Find the boat distance from the marina to the nearest tenth of a mile. So first, it's starting from the marina and heading north 52 degrees east. That means going to north direction, this side on the top half part. 52, the bearing 52 degrees to the east, because north, south, west, east. So it's going to this direction. The angle here is 52. After 1 hour from here to here, the distance from here to here is S equals V times T. V is 6, T is 1. So the distance is 6 miles. It's from M to the A. So after 1 hour, when the boat is got A, it make a counterclockwise turn. So make a 90 degrees counterclockwise turn to a new bearing of north 38 degrees west. That means so here become the new origin. So I can draw a line. This is west, this is east, this is south, this is north. Anyway, so the new bearing is north 38 west. So it's going to here because before it's going to this direction, but make a counterclockwise 90 degrees is going to this direction. And the new bearing is 38 degrees. And here is 90 because from here to here is 90. That means this angle is 90 degrees. Okay, so what's the next step? From here to here, it travels 2 hours. That means the new distance from A to B equals the speed V. That's 6 times the new time. That's 2 hours. That's 6 times 2 equals 12. From A to B is 12. Okay, oh, I see. This is a right triangle, and we know this side, I can find the hypotenuse. That's the question is asking for. The boats, the distance of the boat to the marina equals square root of 12 squared plus 6 squared. So BM, the distance equals square root because it's positive. So here is positive. The distance is positive. And equals 12 squared plus 6 squared. That's 144 plus 36 equals 180. 180, no degrees. Just 180 because this is a mile. The units is mile. Use calculator to find that's square root. Second, in this button, 180. Click enter. That's 13.4. So round to the nearest tenth. That means 13.4. Because here is 1. I don't need to round up 1. Just to say 13.4. So this one equals 13.4 mile. Okay, let's move on to next part. So the same question, number B. Find the bearing required for the boats to return the marina. So from B, I need to go to the marina M. That means origin becomes B. I need to draw a horizontal line and vertical line. So north, south, west, east. That means I'm looking for the angle here because it's going to this direction. That means this ray, the angle between this ray and the north-south line. looking for alpha. We have learned if I have two horizontal lines, two parallel lines. These two lines are parallel to each other. So I have another line pass through these two lines. The angle alpha here and alpha here, they are the same. And if I have two lines like this, they are parallel to each other. So the line here, oh, sorry, not the line. Angle here, and here, they are the same. Angle here, they are all the same. That means look at this image, this vertical line. Alpha here, and this one is also alpha. That means if I'm looking for alpha, that means I'm looking for this angle at the same time. So in this right triangle, we know this side, and can we find, we know this angle, can we find this angle? M, for example, this is M. If we know the M, minus 52, I can find alpha. This alpha is this alpha. So let's find the angle M. The opposite of the M over adjacent M, the tangent. Tangent M equals 12 over 6, that's 2. So the M equals the inverse of 2. So use our calculator. So second tangent 2, close the parentheses. So the M is about 63.4. If we keep tenths of the degree, that means keep 1 decimal point because tenth is here. So that's 63.4. M is about 63.4 degrees. This is M, this is not alpha. Alpha equals M minus 52. So alpha equals 63.4 degrees minus 52 degrees. This one equals 11.4 degrees. Okay, so how to fill the bearing system? So it's going to the north, going to the south. So south goes first, angle goes second, 11.4 degrees. And then since it's in this direction, it's on the east side. So the final angle, the final answer is south 11.4 degrees east. The boat should follow a bearing of south 11.4 degrees east to return the marina. Okay, that's the end of this class, this lesson. If you have any question, please let me know. Okay, have a good one.